H naught into rho m gy. So this one cancel out, and suppose the range for horizontal Venturi meter z1 equal to z2. This height, suppose this is horizontal, this side and this side same, so this also cancel out, z1, this one and this one. So p1 plus p1 equal to p2 minus rho gy plus rho m gy. Understand? So p1 into rho g, p1 minus p2 equal to this p1 minus p2, g common, g and y common, and rho m minus rho. Okay, now from here, now p1 minus p2, rho g divided by both side by rho g, this side, y into gy into rho g minus rho m minus rho gg. So this value, this is equal to h, and gg can cancel out, so y into rho m by rho minus 1. This is another equation where this is the piezometric head difference h. This is the piezometric head difference, and y is the difference of manometric fluid column, where rho m greater than rho in case of y into 1 minus rho m by rho, in case of rho greater than rho m. In case of rho greater than rho 1, this equation this equation will apply. Understand? Now from continuity equation, a1 into v1 equal to a2 into v2. So v1 equal to a2 by a1 into v2. Okay, now h, this is the equation 1, and this value is, this is the equation 2. This is, suppose this is the equation 2, and this value put in equation 1, h equal to v2 square by 2g minus v1 value a2 square by a1 square into v2 square by 1 by 2g. Now v2 square is common, 1 minus a2 square by a1 square, 2g is common also, Understand? 2g is common. So v2 equal to root over 2g by root over 1 minus a2 square by a1 square. Okay, and h value is, we already know, h equal to y into pm by rho m by rho minus 1 for rho m greater than rho, and in case of rho greater than rho m, that case h equal to y 1 minus y into 1 minus rho m by rho. Understand? This is the velocity at section 2. Now the discharge. Main target is to measure. Main purpose is for Venturi to measure rate of flow. The rate of flow is denoted by Q. This is also called discharge. The discharge Q equal to A2 into V2 or A1 into V1. So I already calculate V2 value, so this one wiped. So A2 into 2gh root over a2 square by a1, this value whole square. Okay, or I can write it, this value a1 into a2 root over 2gh by root over a1 square minus a2 square. This is the theoretical value th. Understand? This one from there. Understand? This is the theoretical value, the discharge. So discharge equal to this. This is the discharge, theoretical, and coefficient of coefficient of discharge, CD equal to Q actual or QTH. So Q actual equal to CD. This value is for real fluid. This is the rate of flow for real fluid. A1 A2 root over 2gh divided by a1 square minus a2 square. This is the for real fluid, and this is for ideal fluid. Real fluid. Understand? And H value in terms of specific gravity, Sg, in terms of Sg, y into, this is the difference of manometric liquid column, fluid column, or Sg in manometric, and Sg of minus when Sgm greater than Sg, and y Sg by Sgm, oh sorry 1 minus Sgm by Sg when SG greater than SGM. That equation, use this equation for this is the piezometric, this is the H equal to piezometric head difference. Now some points. Now note down some points. Semi angle, semi cone, angle of converging portion, converging section is 18 to 20 degrees centigrade, and semi angle of diverging section is 6 to 7 degree. Converging this is the this is the converging, this is the semicone angle, and this angle this is the 18 to 20 degrees, and this is the 6 to 7 degree. This is the diverging section, this is the converging section. Now CD value for venturimeter, coefficient of discharge is 0.96 to 0.98. And another point is CD equal to function of CD for function of Reynolds number, surface roughness, and area, A2 by A1 area ratio. This is the Reynolds number, this is the Reynolds number, this is the area ratio. Means CD is depend on Reynolds number, surface roughness, and area ratio. And the value of CD equal to root over H minus HL. This is the piezometric head difference, this is the head loss by H. These 4 points very important for venturimeter. Next measuring device is orifice meter. Number point, orifice meter is a device used for measuring rate of flow of fluid through a pipe. Orifice meter is it is a it is cheaper, cheaper that of Venturi as compared to Venturi meter, as compared to Venturi meter, and it also work on the principle of that of principle principle that of same principle, same principle that of Venturi meter, and it consists of flat circular plate, flat circular plate which has circular sharp edge hole called orifice called orifice, and which is concentric with pipe. Understand my these points. Now the orifice meter. Suppose this is a pipe, this is a fluid is flowing through pipe. Suppose this is the orifice. This is the orifice. This is the orifice. Suppose this is the section 2. This is the section. Sorry. The sharp edge. This is, and this is also. This is the suppose section 2. This is the section. This is the orifice. And this is the pipe. Suppose this is the section 2. Section 1. this is the pipe, this is the pipe, and the diameter of pipe d, and diameter of orifice small d, as small d, diameter of orifice, dia of orifice d equal to d by 2, diameter of pipe. And this is the section 2, from the section 2 this is the d equal to small d, মানে orifice diameters, this length is d by half, and this length is 1.5 d to vary 2d, this length. Understand? From section this is. Now this is the vena, called vena contracta. Vena contracta means, vena contracta means minimum cross section area, cross section area at, this is the, now let P1 equal to pressure intensity at section 1, V1 equal to velocity at section 1, and this is the area A1, area of pipe at section 1, and P1, P2, V2, A2. These are corresponding values, are corresponding values at section 2. Understand? Now applying Bernoulli's equation